Hello everyone, I am Dr. Nikhil Vyavhare and I am assistant professor in department of DIC, which is belongs to data science, IoT and cyber security. Today we are going to teach and learn the topic of computer architecture, which is one of the important topics in the recent trends in computer engineering related world. So, the topic is we are taking under the section of the computer architecture related portion. Here we are going to understand the topic of how mathematical calculation will be performed, and this mathematical calculation will be performed on the basis of ALU, which is one of the basic important portion. And if we consider this is a part of your processor, so there is a one question comes to you that either a ALU is of that number which is to be performed the any operation. So, we can given the information inside it. So, ALU is always required the two information which is the applicant, that is the number part A, and the next part is of you can say the B. So, the result which is going to the any kind of your accumulator, that in the sense. So, we will write over here it is called as accumulator. Then the processor which is we want to declare that having the how much of processor bit is to be there, that means it is of about the ALU, that how much of number of bits that can be performed. So, that means if I will write that A is of 8 bit, then B is also of 8 bit, that means ALU is of 8 bit which is to be performed. That means a processor which is to be we have marked, if we underline this portion, then in a computer architecture system, if this is my CPU, then CPU is also of your 8 bit. So, this is the simple concept which is basically depends upon the ALU factor. Now, why we are going to learn this ALU? Because many of the operations which is performed inside the ALU is arithmetical related operation, and these operation are like addition, then subtraction, then multiplication, and then division related. So, there are the different types of database which is we can have, like your arithmetic point of view in a floating point, then natural numbers, then binary numbers, and many of the numbers which can be performed by the your CPU. So, now CPU are related to the some kind of information which is comes in the part of your data. So, data I can say like it is a floating point. So, this is also very important, because floating point of data that we have to go for the different types of related operation, that is called as the addition. Then we have to also perform the addition related operation which is of your maybe a 2 bit or it is of 8 bit also. Then for most of the time we consider for multiplication and related operation up to the end of part, that is called as we can say the division also that we can perform. Now, this operation is where perform, the operation is going to perform inside the your ALU system. So, this ALU system is completely responsible where the CPU can perform all this operation. So, related to this one, we are going to understand that today's main topic is the Booth's algorithm. So, why Booth's algorithm is important over here? Because the multiplication which is I am going to conduct over here, that the multiplication is a vital information that we can say the any kind of addition or the any multiplication we required, that is a multiplication, that means the multiple recursive, that is the called the cascading of your addition that we are doing. That is why the multiplication is a important portion, and the multiplication that we are going to teach inside your Booth's algorithm, why it is so important. Okay. So, Booth's algorithm is going to give the information related the how the multiplication can be go for the in a faster rate. Okay. So, for the faster rate, can we know about the math processor? Okay. So, math processor is also having the one of the algorithm related to that one. So, the basic algorithm that we are going to understand is Booth. So, in Booth algorithm, what is important? It is related to the 2's complement number system. So, the 2's complement of your basically the 2 bit system, that is 2k to 2 raised to the power of m. So, resultantly it is going to take as a 2 raised to the power of your k plus 1. Okay. So, the value of the your number system is going to this one, and then we are going to minus that number system with the base of your 2. Why the base of 2 is over here? That is the 2, the base that is telling to you it is a base which is my binary number. Okay. So, binary number is majorly taken over here. So, why the binary number we are taking only? So, I also giving you explanation, but there is a particularly a flow chart of this Booth algorithm which is going to start the any simpler process. So, the we are now understanding the Booth algorithm, how it will be performs its operation. So, the first one is the start, any operation that we are going to start from the it starts operation. Then we have to acknowledge the sum of the portion. First one is the accumulator. Initially accumulator is our 0, which is we want, because since the operation that we are going to understand is, if we are taking the 2 bits, that is the A and B, which is of your 8 bit, then ALU going to perform the operation, then the result is coming to over here, that is called as the accumulator. So, my result I do not want in a garbage value, that is why I am going to take as a AC, that is the accumulator is 0. Then by the next number is, that is the coefficient value, which is I am going to take as a 0 also over here. Then my sequence counter is also going to 0. Why sequence counter I am required? Because since if you can see, there are the multiple operations and the performance that we are doing over here. In the sense, it is a number bit of your decimal, but for the 8 bit I am going to take as a binary number. So, the 1 by 1 numbers are going to come over here. So, I will require the sequence of that number, which is until A0 I am doing this operation repeated motion. Next one is my BR as a multiplicand, then I am required as a QR my multiplier. So, these two values I am going to repeat once again, and then I am asking the question to the system, okay, that is the decision is what going to take over here. So, this decision is based upon the two database value, which is depending upon the two factor. First one is Qn and Qn plus 1. So, these two value I am going to take, because here Qn and Q plus 1 I am representing these two one, that is A is equals to, if I write and representation as a Qn, and B I am writing as a Qn plus 1. So, these two operation I am performing over here. So, that is why whenever the values are being coming, and if you take the base of the two system over here, so we can understand that if the base of the binary is 2, that means 2 raised to the power of n. If I represent this 2 with a 2 value, that means 2 raised to the power 2, that means it comes to a 4. So, the simple value is to be said that either it is at 0 0, then 0 1, 1 0 or 1 1. So, these are my 4 values which is represented over here. So, any of these two value, either the system value I am getting consider the two different value, that is the 0 1 or 1 0. So, my concentration is to solve only these two value only. Okay. So, I will not select these two value like 0 0 and 1 1. So, I am selecting these two value. Why? Very simple, because when there is a difference of number is coming, so obviously we are going to acknowledge that. Okay. So, these two different value I am going to understand with a observation of what happen inside the your AC, that is the accumulator. So, accumulator will gives me the AC plus BR bar plus 1 over here. Okay. So, the operation is performed over here, that is for the your 1 0. Okay. That means this operation for the different one number system. If I said that it is a value of A and if it is a value of B, then the two different value I have observed over here, what happens? The accumulator will go for the minusing that in the number of the negative number which is I am required as a BR. What is the BR? My multiplicand number system, that is the reciprocal, that is the 2's complement number plus 1 I have added over here. The next one is the difference number is other than the 1 0 is 0 1. If the second combination will come, then my operation will be performing simple with a positive manner. That is your AC will perform only AC plus BR. So, this is the two operation I am going to observe in every cycle of the operation, which is if I having the A and B, that is of 8 bit. If it is a consideration of the 8 bit operation, then we are going to check the ALU operation, that is the called as a multiplication if you are doing over here inside the your CPU, and how CPU is performing the algorithm by the help of your booths. So, what happens when what happens with the these two numbers, that is the 0 0 and 1 0. So, I will separately passing this number, that is the here, that is 0 0 and 1 1 for these two number system, that is 0 0 and 1 1. Why I have passed this number? Because I am not attracting these two number, because there is no reflection, no change in the value. So, it is either it is a 0 0 or 1 1. So, I will going this number to the pass this number system. Maybe there is some kind of combination which is I have required over here, that is inside the A and B. So, for the next and further operation, which is we said that now we require the arithmetic shift operation. So, I will call the arithmetic shift operation over here. Since why arithmetic shift operation? Because the number is not having the difference. So, either its difference required the 1 0 or 0 1. So, the numbers are passed as a 0 0 and 1 1. So, now I will call as arithmetic shifting of your operation. So, as R to which value, that is the AC, because there is no reflection, that the numbers are 0 0 or 1 1, then BR. Somehow we can also say that it is a plus also symbol, because accumulator and the multiplicand is related to that one. Then I will say that since the number is still continuing value, because only one time operation that we have performed, that is 1 0 and 0 1, here we are not getting the complete answer, for there are the two figure is continuously coming. So, that means my sequence counter is still it is not equals to the 0. So, I will call as a sequence counter which is SC minus 1, that is the sequence with a minusing the 1. So, decrement your sequence. Now, I will go for the operation which is next to be required. For the next operation, if I am writing as a one of the algorithm without notifying any mathematical content, so how I will understand the algorithm or the complete step is performed. So, I have to definitely go for the some looping of this value. So, where I can say that it is a looping of the value. So, I have to ask that it is a sequence of the number. So, I will say that sequence counter, okay, the sequence of this number, I have to continue it until the operation is not getting performed. Okay. So, this number is here I am writing, since the sequence counter is not equals to 0, hence you can go further and perform the same operation over here. And if I will conclude that, because this is the algorithm and there are the two numbers which is to be performed. So, the sequence of the number is to be now completed. So, equals to the 1, then I will say that the operation is performed. So, this will be my ending of operation. So, this is the simple way to understand how Booth's algorithm is going to perform with the two numbers which is having the weight of the value is from the 2k to the 2m minus that is the 2k plus 1 minus of your 2 raised to the power of m. Here the binary number system that we have considered. If we consider the binary number of your sequence of your 2 digit number value with a base of 2. So, my total combination will comes as a 0 0 0 1 1 0 and 1 1. Henceforth, all the combination which is put it inside your algorithm, it will definitely comes to end of the sequencing the number, whether the until the value is not going to 0, the sequence of operation will be performed as it is, and hence we are going to discover the fastest multiplication which is we required inside the your ALU. Hence, the ALU is performing the operation for the CPU process. So, this is called as your Booth's algorithm. So, this is the operation that I am going to perform and we can have the one mathematical implementation also. So, this will we can take as in a next class. Thank you.